this is just a quick video to, hopefully a quick video, just to outline my theory of scale-free network of evolution for early mankind. So to begin with, we'll start off looking at this Medium article that I came across. It's from John Hawkes, paleoanthropologist, and it has some interesting information here. So it starts off, 4 years ago, the story of modern human origins seemed fairly simple. Modern humans originated in Africa sometime around 200,000 years ago. Some modern people spread into other parts of the world sometime after 100,000 years ago, mixing a bit with archaic human groups they met along the way. New discoveries have shown just how oversimplified this picture was. The common ancestors of today's modern humans lived a lot earlier than we thought, and we can't connect them to the fossil record. They were far from alone. Africa was full of other groups now extinct, and some of them mixed Neanderthal-like into living populations. So he goes into a couple of examples of strange goings on within human history, discovered by geneticists and paleontologists. So paleoanthropologists, I should say. Modern humans share a lot with each other. We're 99.9% genetically the same, and that's impressive. That impressive genetic similarity comes from inbreeding. So one problem is the bottleneck concept. So there was a bottleneck sometime. Was it not sure when, about 100,000 years ago, possibly. But so basically the story is that early humans left Africa around 200,000 years ago, and the ones that left experienced the bottleneck in genetics. So basically they're saying that most of them got wiped out, and so all the people who are not from Africa or Australia in particular, are only descended from a very small group of ancestors, like one or two. They can all be traced back to this one female, I think, called Eve. I might be oversimplifying a bit, but so that was a new discovery right there. What were some of the other ones? Ghosts. Right, this is an interesting one. Ghosts haunting our origins. So far, nobody has recovered ancient DNA from archaic human skeletal remains in Africa. The 2,000-year-old Bolito Bay boy is not the oldest, but there are no DNA results from truly archaic specimens, like the Kebwe skull from Zambia. As a result, we don't have the kind of record within Africa that geneticists have built for Neanderthals and Denisovans in Eurasia. But a series of genetic studies on living Africans have succeeded in identifying signs of mixture from ancient people. This is an interesting point. The genetic diversity of Europeans is actually far less than that which is found in Africa, and the reason for that is like if we look at the theory for out of Africa, one of the possibly good pieces of evidence for the theory is that when people left Africa, if they did, and moved to Eurasia, they interacted with the Neanderthals. So Europeans are meant to have some amount of Neanderthal DNA, although it's not. That might be overturned as well. It may not be as large a contributor as was first indicated in the media and such. But so obviously, like, if humans had left Europe and gone to Africa, then we would if it was the opposite way around, an out of Europe theory, then we would expect Africans to have some Neanderthal DNA as well, but we don't see that. But interestingly enough, we see that Africans mixed with an even greater array of homonyms. So, precursors to Homo sapiens, which is us. There was Homo erectus, which is basically a stone tool using early hominin of Homo sapiens. And if we look at the genetic information of Africans, we see that they have a lot of admixture with these early homonyms, and that's partly what makes them so diverse. That and environmental isolation over long periods of time. But let's suggest that if we go with the out of Africa theory, then humans started off in South Africa, they believe, around 200,000 years ago, although that date is shifting back and back now, as we'll get into that later on. But and then they would have moved up through the continent of Africa, meeting all these early homonyms along the way and interbreeding with them. And then finally they would have gone out through Egypt and up into Eurasia and on that way from a east-west direction. So if that's the case, then we would expect that all of the populations in Eurasia and Southeast Asia, Australia and America would all share these same ghostly genetic markers that the Africans have, because it took them 100,000 years to travel up Africa, and in that time they would have undoubtedly come into contact with these early homonyms and interbred. There's no way that they just shot up through the continent and got out without interbreeding. So if you think about it, if the fact that Africans don't have Neanderthal DNA is a reason to conclude that Europe isn't the origin of humans, early humans, then you have the same problem with the Africa theory, because the rest of us don't share the early hominin DNA that Africans have. So if one is precluded because of genetic evidence to do with interbreeding with early hominids, the other one must also be called into question by the same logic. Now, the reason why there's so much backing for the out of Africa theory is obviously because of human remains and but more specifically stone tools that are found in the region. Because if we look at Earth Ancients YouTube channel, a video called Mankind's Ancient Origins Out of Africa Theory is Wrong, they list numerous evidence of humans in India 3 million years ago, Homo erectus in Indonesia about 1.2 million years. Also, all of this is far before the fossil evidence in South Africa, which is 200,000 years ago. We also have Homo erectus in the Caucasus Mountains 1.8 million years ago. And we even find in South America evidence of Homo erectus 200,000 years ago to 400,000 years ago, and possibly even earlier than that. So the three, in that video, the guy outlines, I couldn't get his name, but he outlines the three competing views of the origins of early man. And the first one is obviously out of Africa that we're dealing with at the moment. And then the one that he subscribes to is the origins from Southeast Asia and Australasia, moving up into Asia and then Africa, or straight to Africa as well. It could be another issue. And the third one is multi-regional, that humans just developed all over the globe at the same time. Now, like I said, he favours the Southeast Asia model, which is an origin model, But he also mentions that Homo erectus was global prior to the emergence of Homo sapiens. So that's an interesting point, and one that I will build on later with my own theory of scale-free origins of early humans, which is really just the multi-regional theory, but with some added caveats, let's say. Now, one thing that I found very interesting from this Medium article, and that I didn't know of, was just how recent some of the interbreeding between Africans and these early hominids were. Like, you'd imagine it had happened hundreds of thousands of years ago, if not millions of years ago. But in fact, it's very difficult to see. This is one of the problems with trying to study this thing from a genetic point of view, because you can't actually tell by looking at the genetics when the interbreeding happened. But there's obviously ways that they can guess. But they don't, and without genetic information of the early hominids, they also can't say what comes from an early hominid and what doesn't. In some sense, they can guess, certainly, but they can't be sure. But I think that their guesses are still pretty correct. So I think there's it seems to be suggesting that some of this interbreeding happened 236,000 and 335,000 years ago, but I thought it might have been even earlier than that. Oh, the dominant stream that the streams. All right, so these are the streams he's talking about here are different species of early hominid that interbred with man. The dominant stream, that special population of human ancestors, lived sometime before 260,000 years ago. Jebel Irhoud might have been on the mainstream. So Jebel Irhoud is some sort of early hominid, or it might have been part of one of the minor contributing archaic groups. So you see what they're saying, they don't know, you can't tell what's mainstream, what's tributary. It's all quite muddled the further you go back. And they're saying, or it might belong to a still more distant extinct branch. Its facial features inherited from very ancient ancestors like Homo antecessor, and marking no special relationship with any modern humans. So you see they're saying that possibly this hominid didn't interbreed with humans, but interbred with a species prior to dying out, and then that species might have interbred with humans. So it's a bit like finger painting in the dark. No one's really sure of the time scale, what paint was laid down first and what came after, because it's all just mixed together. Okay, I think that's quite a good analogy. So if we look at my theory is based on scale-free networks. So this used to be, I thought this used to be called free scale networks, but I don't know, obviously I was wrong. Free scale network is a network with degree distribution whose degree distribution follows a power law at least asymptotically. So this is quite a technical page, but we have some nice pictures here that we can look at, which always helps. So we have random network and free scale network, and a random network scale free. In the scale free network, the larger hubs are highlighted. So basically, in a scale free network, we do have certain centers, and things branch off from them. I'm not exactly sure if my theory is scale free or random. Perhaps we can look at it and decide which model best fits this new way of looking at humans' early origins. And the purpose of this new theory is to debunk or call into question the out of Africa theory. Now, before we start, it'll be a good idea to look at the current status of research into race and genetic difference. So here we see that we have the 8 genetic groups of which all humans belong to. So we have African, Caucasoid, Northeast Asian, Arctic, American, South Asian, Pacific Island, and Oceanian. Now, so if we go back, this is, let's say, 200,000 years ago, but obviously we have, let's just go with that for the moment. We're definitely pushing it back, possibly millions of years prior to that, but let's just start with this. So there's a branching point from, this is South Africa, and then it branches up into North Africa, Ethiopian, West Africa, all these different tribes here. Then, and at the same time, it goes down this way to form the Australasian groups. So these two are happening more or less at the same time, which is quite strange, I think. New Guinean and Australian, like how do you jump from Africa to Australia? But this is seemingly what the evidence is saying. And then also up through Polynesia, Melanesia, and Micronesia as well. And then while that branch point is going on, we also have you know, people moving up into Africa, or sorry, up through Africa, possibly to Europe, and then you also have the Asian communities and Indian communities, so Korean, Japanese, Ainu, and all of those. So I think that gives you a good idea of the tree node model that's currently in effect in paleoanthropology. But I'm going to give you a more simplified model of it here. So again, tree node network, and the reason why I'm simplifying it is just so, you know, to reduce the parameters so it's easier to understand. So to begin with, there's no label up here. This is Homo erectus, some form of early human hominid ancestor, that the missing link essentially. So there's no tag here because we don't know what this is. But it comes down, and then at this point it branches. So this is South African early hominid 200,000 years ago, and it branches into, as we see, 4 separate lineages over time, and these are W, X, Y, and Z. And these 4 lines down here are 4 different races, and these characteristics down here, A, AB, AC, and ACD, are all different genetic markers which express different random mutations that all build on the original genetic code of W. So obviously they come down here, there's an evolution into Homo sapien, and the long line of South African early humans, and we can look and see that their genetics expresses that in the form of A. A is also a marker that is found in the group that moves to North Africa, which is X, and they have A, as we'd expect, following on from this group, but they also have a slightly different genetic effect based on their own isolated evolution history, which is B. At the same time that they're moving into North Africa, there's also a group moving into Australasia, and they express a slightly different genetic variation, which is C, but they still have the original A marker. Obviously they don't share B with this group because they're separated from over millions of miles and hundreds of thousands of years. And branching off from the Australasian population, we have, let's say, the European population or Caucasian population, which expresses A, which shows that it is related to the W line. It also has C, showing that it is related to the Y lineage or Australasian lineage. And finally it has its own racial marker to which we can distinguish white people from other races, which is D. So that's its haplogroup. Now, in the scale-free network model, we start over here. Imagine a timeline down here running from 200,000 years, so this would be the 100,000 year mark, up to the present day. Again, we see the four root races, or the four lines here representing the four lineages of the different races that we're examining. W being the South Africans, X here being the North Africans, I believe so, and Y being the Australasians, Z being the Caucasoids. Now, that is correct. X, Y, Z. Did I get that right? I did. Very good. Okay, so in this scenario, I'm positing the idea that the ancestors of humans, which is, and this is backed up by research, that Homo erectus was a global species, actually, and that it had spread all over the earth prior to the emergence of Homo sapiens. And also it would have encountered different kinds of hominid as it possibly moved around. So there might have been different variants, and then it would have interbred with those humans to create different lineages. But let's just keep it simple and imagine just general natural selection sort of forming the different racial groups. But before we do that, let's just look at the original line. So this line here is a straight line because Homo erectus is already everywhere across the globe. And we see that W, X, Y, and Z, they're all on the same plane, even though W is an unknown. So initially they were all unknown, but then these three groups, the let's say the North Africans, the Australasians, and the Caucasians, all develop some new genetic marker, which we'll call A, and that means that they have now evolved from the early hominids, Homo erectus, into what we call modern day humans, Homo sapiens. So from this point of view, already the out of Africa theory is brought into question, this one. So let's say that the Caucasoids, they go along here, and then around 150,000 years ago, they develop a new genetic marker. So they evolved due to natural selection and environmental pressures. So all these groups have already evolved once, possibly through interbreeding with other early hominids, and they spread globally. But now this group, the Caucasoids, develop their own genetic marker, which is C, which distinguishes them from the other two groups of Homo sapiens, A and A. So they have A and they have C. Then they go along here, and then they move down to Australasia, India, Southeast Asia, that kind of area, and interbreed with our Australasian group. So it's probably somewhere around India. I'm suggesting this happened. Then those groups continued on, and then they express the AC marker. So here already we have a different solution to the problem. It is not that, as we saw in the tree node model network, that the Australasians are the ancestors of the Caucasians, but rather the other way around, Caucasians ancestors of the Australasians. So and then after those people spread down there, the group that remained and didn't move out developed a new marker, D. So that's what it looks like this came first because it's ACD, but in fact they both share the same ancestors. It's just that these people didn't alter as much as these people afterwards. A similar situation happens in North Africa where there's even less change for a longer period of time. And then they moved back down into South America, giving the Homo erectus down there the A classification, while they continue on to interbreed with Homo erectus populations in North Africa to develop an AB haplogroup, distinguishing them from their earlier ancestors. So once again, there was no Homo sapien line here until the global Homo sapien group came down in through North Africa, down to South Africa, gave the South Africans the early Homo sapien gene, and then continued to evolve themselves through interbreeding and environmental pressures to develop a B. So, like I said here, we have the W, which it appears that the group branches here, and you get A, and then North Africans develop an AB. So it seems logical to go A is first, then AB. However, in the free scale network, we can see that the North Africans have the A first, while the South Africans don't, and then they gift it, in a sense, to the South Africans, and they develop a new haplogroup. So this completely turns it on its head, because the more recent group are the South Africans in this model, and the most sort of advanced group, being ACD, is actually would kind of be seen as the ancestors for all of these. So we was kings, as they say, according to this model. Okay, so one final point then to make is that while the tree node model gives us a lineage line that could be written A first, then goes to AB and or AC, and then goes finally to ACD. So A, AB, A and or AC, and then finally AD. So going along this way, these free scale network gives us an entirely different origin line, which begins as A in brackets, and then AC comes next, going to and then ACD, and then AB, finally AB. So when we compare these two, then we see that from the same data set, just by interpreting the data differently, we get a completely different order of events, with and finally actually with A being the most recent. So it's completely turned it on its head almost, with the exception of AC and AD, which have just moved backwards. But the reason why I say A is the most recent, of course, even though it appears first, is because we think of the South African ancestor who simply has the A marker as being the earliest in the tree node model, but in fact, based on the free scale free network model, the South African hominid or Homo sapien actually arrives the latest. So okay, so thanks for watching. If you like this video, leave a like and subscribe.